consider the graph 3 on x, which is actually this graph over here. This is the function of 3 on x. So on this graph, we're told that there is a point F on the curve, and this point over here, and this is 1, 3, with a point with a coordinates of 1. We can mark that point down here on the x-axis, and that's 1, and on the y-axis it'll be 3. Now we have another point M, and we want to find out what is the y-coordinate of M. So let's look at this M and draw our line over here. Now we're told that this x-coordinate is a distance of h away. So it's actually called 1 plus h from 1. What are we going to make of the y coordinate in that case if x is equal to 1 plus h? Well, we know that our function is 3 over x. So if I write over here f1 plus h is 3 over 1 plus h. So we know that our y value here is going to be 3 over 1 plus h. So we've got all our coordinates at this point. So we've done question 1a because all it asked is what is the y-coordinate of m? We found the y-coordinate of m. So let's go now to question part 2, and that was to show that 3 take away 3 over h plus 1 is equal to this. This is straightforward algebraic manipulation. So I'm going to go to the right here and rewrite this again. 3 minus 3 over h plus 1. And we want to show that it is this. Okay, so let's go. You know that 3 is the same. We could rewrite this again as 3 over 1 minus 3h plus 1. Now, how do we put them under the same denominator? We do what we call that butterfly effect that I've been talking about, and that means that we actually multiply this with this, and we multiply this with that, which just looks like a butterfly, and then we consolidate the bottom and multiply 1 and that to make it a common denominator. So let's try and do that. Okay, so that will become 3. Remember the brackets. If you don't do the brackets, you're going to be in real trouble. Minus 3 times 1 over, and here we've got just 1 times h plus 1. To simplify this further, all we do is 3h plus 3, expanding that, minus 3 over h plus 1. Now you'll notice that the 3's cancel out and we are left with 3h over h plus 1, which is what we wanted to show. Okay, that is our part 2 of this question. Let's do the part 3. This time we want to find the slope of FM in terms of h's. So let's have a look at the slope of FM. The slope of FM means that I'm going to have to draw a line from F to M, and I want to find the slope of that particular line. So the slope is the y over the x, okay? So what we're looking for is the rise in y over the rise in x. Well, first, let's identify that particular, I'll try to make it black. Let's identify the point, contact point M. That point over here, when we examined it, was the x value was 1 plus h, and the y value, and I like to put them in brackets again, and the y value was 3 over 1 plus h. Once again, I'll be finicky and outer brackets. So we've got the 2 points. Now, you know that to find the tangent or the slope of any point, what we need to do is to determine the y step over the x step. So slope of Fm is equal to y step over x step. Y step is y minus y1 over x minus x1. What is actually y? Y is this, and y1 is this point, x is this, and x1 is this point. So we are now going to substitute in there, and we say 3 take away 3 over 1 plus h over 1 take away. Remember to put this in brackets or else you're going to be in trouble, okay? Because that minus refers to 1 plus h. Now that we have this, it's a matter of simplifying it. And once again, we've got to simplify it by thinking that rewriting this, 3 over 1, take away 3 over 1 plus h, all over 1 minus 1 minus h. I've simplified this as well. You can see that actually I'm going to be able to delete 1 and 1 because 1 minus 1 is just minus h. The numerator needs to be worked through in the same way that we did before when we were working on question 2, when we used that butterfly effect over here. So we're going to use that butterfly effect over here as well. That will mean that this is 3 multiplied by 1 plus h, take away 3 multiplied by 1 over 1 multiplied by 1 plus h, and then we also need to divide it by minus a half. So I can write that not minus a half, but by minus h. Now that's going to be, I'll do this in green so that you can actually see it. Because that minus h is there, we can rearrange this so it'll look like this. So let's rewrite this again. 3 plus 3h minus 3 over 1 plus h. Where are we going to put that h? Well, we can put that h right over here now, because that can be seen as minus h over 1. So I can now multiply it by reversing that, and it comes up into the denominator over on this side. What I was trying to say is that we could, let's say for instance, I have 3 over 4 and I'm dividing it by 5. 5 can be seen as 5 over 1, and this whole equation can be seen as 3 over 4 divided by 5 over 1, which is really the same thing as 3 over 4 multiplied by 1 over 5. So I just did the reciprocal of 5 and I multiplied it, and that's what we are doing in this particular case as well. So we've got minus 3. Now, we can actually take 3 and 3, cancel that out. So we're left with 3h over 1 plus h. And we've got also a minus, put that in brackets, and we also have a minus h in here. This is where the trick comes, because you've got to be able to realize that that h and that h can be now cancelled out. Be careful that you don't cancel the negative, because the negative's still there. So we are left with 3 over 1 plus h, and we still have that negative sign there, okay? It'd be better written like this, 3 over 1 plus h, and we can just put the negative right in front of this whole equation. And that makes sense because this is the slope, okay? The slope. And if you notice, the slope is negative, which is true because the slope of fm is a negative slope. So now comes that tricky question where you're asked over here to, using this expression, state the slope of the tangent at f. So if we back down to our graph and we have a look at f, and now make it really nice and big, if I could do that, and you're looking at f, what you're seeing is this, that is the slope of f to m. If I wanted it just at f, which is just here, this bit over here, I need to bring that m towards the f. So I'm going to move that so that tangent, I'm going to move it closer and closer and make that tangent even shorter and shorter. What am I actually doing with that value h? I'm actually bringing that value h closer towards 1. So it is no longer 1 plus h. I am actually, put this over here, what I'm doing is, as saying this now, I'm saying that as, oops, wrong one, as h goes to 0, slope fm, this is fm, okay, this is the slope of fm, now goes to the slope of tangent, okay, move it up, at f. Therefore, slope of tangent at f is equal to minus 3 over 1, because my h now becomes 0. So it is just minus 3. The second part of the question is similar, and I'll just make this all nice. That wasn't part of that answer. The second part of the question, which is not here, but I will do it in the next video, is very, very similar. So I'll make another recording. Thank you.